Bismillahirrahmanirrahim. Assalamu alaikum. Welcome to F6 online sport program. I hope you all are fine. I'm your teacher Umaira Nawaz from Army Public School, Gujranwala, Kent. Today I'm here to present 10th week assignment of chemistry for class 8. My dear students, we are still continuing our second chapter of chemistry, that is structure of atoms, which is on your book page number 36. Today our topic is electronic configuration. My dear students, before starting our this week assignment, we are taking a recap. What we have learnt in previous week. Do you remember? Yes. Isotopes. We learnt about isotopes. We also learnt about different isotopes of hydrogen, carbon, chlorine and uranium. We also discussed about uses of isotopes. Objectives. Students will be able to learn about shells and subshells of an atom. Students will be able to memorize the tricks for electronic configuration. Students will be able to do electronic configuration of different atoms. Now we are going to start our this week assignment. Electronic configuration. To understand electronic configuration, you should know about shells and subshells. So what are shells? According to Bohr's atomic theory, the electrons in an atom revolves around the nucleus in one of the circular paths called shells or orbits. Each shell has a fixed energy, so each shell is also called energy level. Each shell is described by an N value, where N is principal quantum number. This picture is for potassium atom. Potassium atom is represented by symbol K. As you see in the picture, electrons are revolved in circular path called shells. What is principal quantum number? The principal quantum number N describes the energy of an electron and the most probable distance of the electron from the nucleus. In other words, it refers to the size of the orbital and the energy level an electron is placed in. N can have values 1, 2, 3. When N is equal to 1, it is K shell. When N is equal to 2, it is L shell. When N is equal to 3, it is M shell, etc. As you see in this picture, when N is equal to 1, it is K shell. When N is equal to 2, it is L shell. When N is equal to 3, it is M shell. And when N is equal to 4, it is N shell. As the value of N increases, the distance of electron from the nucleus. This picture, blue ball is nucleus. As the value of N increases, the distance of the electron from the nucleus and the energy of the shell increases. Subshells. A shell or energy level is subdivided into subshells or subenergy levels. Subshells are labeled as S, P, D, F, etc. in an electron configuration, where S stands for sharp, P stands for principal, D stands for diffuse, and F stands for fundamental. So my dear students, how many electrons these subshells can hold? S subshell can hold 2 electrons. P subshells can accommodate maximum 6 electrons. D subshells can hold 10 electrons. And F subshell can hold 14 electrons. I hope you understand. My dear students, this is the rule for writing electronic configuration. N value of a shell is placed before the symbol for a subshell. For instance, N is equal to 1. It is K shell. It has only one subshell, which is represented by 1s. N is equal to 2. L subshell. It has two subshells, which are 2s and 2p. N is equal to 3. M subshell. It has three subshells. As you see, three subshells, designated as 3s, 3p and 3d. N is equal to 4. N subshell. It has four subshells. These are 4s, 4p, 4d and 4f. My dear students, now tell me, what is the difference between shells and subshells? Yes, you are right. Shell. It is a pathway followed by electrons around an atom's nucleus. Shell can hold up to a maximum of 32 electrons. Subshell. It is a pathway in which an electron moves within a shell. Maximum number of electrons this can hold depends on the type of subshell. So what are subshells? Remember? Yes. S, P, D, F. These are subshells. Subshell filling order. Electrons will fill subshells in the order of increasing energy of the subshell. The order is 1s, then 2s, then 2p, then 3s, then 3p, then 4s and so on. 1s subshell is closest to nucleus and has lowest energy. So 1s subshell will fill before a 2s subshell. Electrons are filled according to above principle. So what is above principle? According to this principle, electrons fill the lowest energy subshell that is available first. This means electrons will fill first 1s, then 2s, then 2p and so on. Filling order memory aid. The diagram provides a compact way to remember the subshell filling order. This is called the diagonal rule for electron filling. The correct order is given by following the arrows from top to bottom of the diagram. Following the arrows from top to bottom of the diagram. Going from the arrow tail to the head. And then from next tail to the head. N is the principal quantum number and 1 represents the number of shell and 1s represents the subshell. From following tail to head, then from next tail to head, then next tail to head and so on. After filling the electrons, the arrangement of subshells are 1s, 2s, 2p, 3s, 3p, 4s and so on. Students, I have a video for you related to this topic, shells and subshells. Hope so it will help you to understand this topic in better way.
Shells and subshells. According to the Bose-Atomic model, electrons resolve around the nucleus in stationary energy levels called orbits. These orbits are also called as principal energy levels, or shells. These energy levels are represented by principal quantum number, n, which assumes only integral values, 1, 2, 3, etc. The shells are also represented by letters K, L, M, N, etc. The energy of the shell goes on increasing as the distance of the shell increases from the nucleus. For N equals 1 electron is present in the first shell K. For N equals 2, it is present in L shell, etc. The energies of electrons of the shells increase from K shell onwards. The number of electrons in any shell is given by expression 2n square, where n equals 1, 2, 3, etc. Hence, K-level shell contains 2 electrons. L shell contains 8 electrons. M shell contains 18 electrons. N shell has 32 electrons. O shell has 50 electrons.